Hi everyone, my name is Carolina and my partner is Ariel. Today I'm going to talking about 3.6, a summary of curve sketching, which is a course from AP Calculus AB. And this chapter is about how to sketch a curve. Firstly, we should determine the important value to find and use while analyzing a graph and its derivative. We also should describe how the function f of x behaves from the graph of f of x, f prime of x, and f double prime of x. Firstly, in terms of how to draw the graph of f of x, we should find whether the graph is increasing and decreasing, and it mainly means that we should determine where the graph A is going up or down. Secondly, we should find the relative maximum or minimum, which means the top of a hill or bottom of a valley. Thirdly, we should find the critical points. Critical points is when the first derivative of f of x equals 0, and it can help us to determine the relative maximum, minimum, the sharp turns, or the vertical tangents. And we also should determine the concavity of the graph of f of x, where the graph is cupped down or up. And lastly, we should determine the points of inflection, where the second derivative equals 0, and it can help us determine the concavity. In terms of the graph of f prime of x, we should see where the graph is increasing or decreasing. It is where the graph is positive or negative. Secondly, we should find the relative maximum or minimum, where the graph changes from positive to negative. Thirdly, we should determine the critical points, where the graph crosses the x-axis or where the graph does not exist. And we should find the concavity, where the graph is increasing or decreasing. Lastly, we should determine the point of inflection, the top of a hill or bottom of a valley, and it is the relative maximum or minimum of the graph of prime of x. Lastly, in terms of how to draw the graph of f double prime of x, we should see the concavity, where the graph is positive or negative. And lastly, we should determine the points of inflection, where the graph crosses the x-axis. In terms of the first example, the graph of function f of x is given. For the graph, what are the critical points, intervals of increasing, decreasing, what are its relative maximum, minimum, and its points of inflection, and where it is concave up or down. And this is the graph given. Firstly, because this is a graph of f of x, the critical point is when the first derivative of f of x equals 0. And in this graph, it is when the graph have a horizontal tangent line. So definitely we can see from the graph that it is when x equals -4, x equals 0, x equals 2, or x equals 4. And when the graph is increasing, it is when x between -4 and 0, and x between 4 and positive infinity. When the graph is decreasing, it is when the f of x from negative infinity to -4 and 0 to 4. The relative maximum in this graph is when x equals 0, and the relative minimum is when x equals -4 or x equals 4. The point of inflection is when x equals -1, x equals 1, x equals 2, and x equals 3. When the curve is concave up, it is when x equals negative infinity to x equals 1, and x equals 1 to x equals 2, and x equals 3 to x equals positive infinity. And when the curve is concave down, it is when x equals -1 to x equals 1, and x equals 2 to x equals 3. The second example, the graph of derivative function at g of prime of x is given. For g of x, what are the critical points, intervals of increasing, decreasing, what are its relative maximums, minimums, its points of inflection, and where it is concave up or down. And this is the graph of g of prime of x. So the critical points is when the first derivative of g of x equals 0, and in this graph, it is when the curve crosses the x-axis. So obviously, it is when x equals -4 and x equals 2.5. When the curve is increasing, it is when the graph of g prime of x changes from has a positive gradient, so it is when the graph above the x-axis. So it is the x equals negative infinity to x equals negative 4 and x equals negative 4 to x equals 2.5. When the curve is decreasing, it is when the graph of g prime of x is below x-axis. So it is when the x equals 2.5 to x equals positive infinity. In this graph, the relative maximum is when x equals 2.5 because the maximum point is when the gravity changes from positive to negative. And in this graph, because the curve crosses the x-axis when x equals 2.5 and the gradient changes from positive to negative. And similarly, we can find the minimum point, which is none. And the point of inflection is when the second derivative equals 0. And in this graph is when the curve has a horizontal tangent line, and it is when x equals negative 2 and x equals 3. So the curve concave up when x equals negative infinity to x equals 2 and x equals 3 to x equals positive infinity. The curve concave down when x equals negative 2 to x equals 3. This is another example. Given the graph of the second derivative h of double prime of x is given. For h of x, identify points of inflection and where the graph is concave up or down. The points of inflection equals x equals 2.5, where the curve crosses the x-axis, and the curve concave up when x equals negative infinity to x equals negative 4, and when x equals negative 4 to x equals 2.5. It is merely when the curve is above the x-axis, and similarly when the curve is below the x-axis, the curve is concave down, and it is when x equals 2.5 to x equals positive infinity. Here is the summary of curve sketching assignment. The graph of g of x is shown below, so we also need to find the features of the graph of x. Firstly, the critical point is when the first derivative equals 0, and in this graph it is when the curve has a horizontal tangent line, so it is when x equals negative 3 and x equals 0 and x equals 2. And the curve is increasing from x equals negative 3 to x equals 0 and x equals 2 to x equals positive infinity. The curve is decreasing when x equals negative infinity to x equals negative 3 and x equals 0 to x equals 2. The relative maximum is when x equals 0. The relative minimum is when x equals negative 3 and x equals 2. The points of inflection is x equals negative 1, x equals 1, x equals 3, and x equals 4. The curve is concave up when x equals negative infinity to x equals negative 1, and x equals 1 to x equals 3, and x equals 4 to x equals positive infinity. The curve is concave down when x equals negative 1 to x equals 1, and x equals 3 to x equals 4. The second example. The graph of h of prime of x is shown below. Describe the graph of f of x. And this is the graph of h of prime of x. So the critical points is when the curve crosses the x-axis. So obviously from the diagram, we can see that it is when x equals negative 2, x equals 1, x equals 2, and x equals 4. The curve is increasing when x equals negative infinity to x equals 2 and x equals 1 to x equals 2. The curve is decreasing when x equals negative 2, x equals 1, and x equals 2 to x equals 4, and x equals 4 to x equals positive infinity. The curve has a relative maximum at x equals negative 2 and x equals 2, and the curve has a relative minimum when x equals 1. The curve has a point of inflection when x equals 0, x equals 1.5, x equals 3, and x equals 4. The curve is concave up when x between 0 and 1.5 and between 3 and 4. The curve is concave down between x equals negative infinity to 0 and x equals 1.5 to x equals 3 and x equals 4 to x equals positive infinity. The third example is that the graph of g of double prime of x is shown below. Describe the graph of g of x. And this is a graph of g of double prime of x. So the point of inflection is when the curve crosses the x-axis, and it is when the x equals -5 and x equals 0. The curve is concave up between x equals -5 to x equals -3.5 and -3.5 and to 0. The curve is concave down between x equals. The curve is concave down. The curve is concave down between x equals -3.5 to x equals 0. Fourthly, given the graph of k of prime of x, describe the graph of k of x. And the critical point is when the curve crosses the x-axis, and it is when x equals -5, x equals -2, and x equals 1.5. The curve is increasing when x between -5 to -2, and the x between -2 to 1.5. The curve is decreasing between x equals -infinity to x equals -5, and x equals 1.5 to x equals +infinity. The curve has a relative maximum when x equals 1.5. The curve has a relative minimum when x equals -5. The curve has a point of inflection when x equals -4, -2, 0, 2.5, and 5. The curve is concave up between x equals -infinity to x equals 0, and x equals -2 to x equals 0, and x equals 2.5 to x equals 5. The curve is concave down when between x equals -4 to x equals 2, and x equals 0 to x equals 1.5, and x equals 5 to x equals +infinity. And here is all our presentation. Thanks for listening.